Hi, this is Maggie. In this video we're going to answer the question, what are binary numbers? If you haven't already watched the video that answers the question, what is a number base, I suggest you watch that video first and then return here. Binary numbers are numbers in the base 2 number system. This means that there are 2 digits to count with, 0 and 1. It also means that the positions in the place value number system for binary numbers are the 2 to the 0th position, or 1s, the 2 to the 1st position, or 2s, the 2 to the 2nd position, or 4s, the 2 to the 3rd position, or 8s, and then the 16th position, the 32th position, the 64th position, the 128th position, and so on. When you see a string of 1s and 0s, you might assume it's a binary number, especially if the numbers are placed into groups of 3 or 4, and if they're not separated into groups of 3 by commas. A string of 1s and 0s could be a number in any number base, though, because all number bases include the digits 0 and 1. In a programming context, you might see a clue about the base of a number if it is not in base 10. For example, in Python, you might see a binary number prepended with 0b. When we count in the binary number system, we begin in the 2 to the 0th position, or 1's position, and we count 0, 1, and then we have run out of digits. So just as we do in base 10, we add 1 to the digit in the next position, in this case the 2's position, and reset the current position to 0. So after we count 1 in the 1's position, we add 1 to the 2's position and reset the 1 in the 1's position to 0. That number, 1, 0, is 2 in base 2, a 1 in the 2's position, and a 0 in the 1's position. Take a moment to compare that to the equivalent counting situation in base 10. We reach the last digit in base 10, which is 9, so we put a 0 in the 1's position, and we add 1 to the digit in the 10's position, giving us 1, 0, or 10. We can resume counting in the 1's position, giving us 1, 1, or 3, a 1 in the 2's position and a 1 in the 1's position. But now, if we want to continue counting, we have run out of digits again. So we reset the 1's position to 0 and add 1 to the 2's position, but again we have run out of digits, so we reset the 2's position and add 1 to the 4's position, and we get 1, 0, 0, or 4, a 1 in the 4's position, a 0 in the 2's position, and a 0 in the 1's position. If we keep counting, we get 1, 0, 1, or 5, a 1 in the 4's position and a 1 in the 1's position, and then 1, 1, 0, or 6, and then 1, 1, 1, or 7, and now again we're going to have to reset a lot of positions to 0 and put a 1 in a new position, the 8's position, for 1, 0, 0, 0, or 8. This table shows you the binary numbers up to 15. You might notice a few things about the binary numbers. First, there are 16 numbers here, 0 through 15. Second, we can figure out what number we're looking at by adding up the positions of the 1's. This number, for example, is 11, a 1 in the 8's position, a 1 in the 2's position, and a 1 in the 1's position. 8 plus 2 plus 1 is 11. Look for other patterns in the table and make sense of the patterns you see. Figure out why those patterns exist and what the equivalent patterns are in the more familiar base 10. Try answering some questions and solving some problems. Maybe talk them through with some friends. And when counting in the binary number system and reading binary numbers makes perfect sense to you, you're ready to move on.